So here, this is a spherometer, and this is used to measure the radius of curvature, suppose of a lens or any curved surface. So how to do that? Now before going to the measurement, I want to show you something here. See, this spherometer actually has two scales, just like the previous instruments I was talking about. And here, this is the main scale, if you just see, and this is the circular scale or the vernier scale. So here I'm just making sure that here the circular scale or the vernier scale touches the zero, so that I can show you something here. Okay, and the vernier scale is also at zero here, and the main scale is also at zero. I think now you can see it clearly, right? So the vernier scale is at zero and the main scale is also at zero. Okay, so if from here we give it a rotation, give the vernier scale a rotation, see, here it completes one rotation. It has shifted by 1 unit along the main scale. Just see it. It has shifted by 1 unit along the main scale. And here you can see we have 100 divisions along the circular scale. See, it just starts from 0 and all the way to 90 here, then to 95, then to 100 over here. Actually 100 is not marked in the same place of 0, but obviously you can realize that it has 100 divisions here. So if we just go to the calculation part right now, see, one main scale, the main scale, this is the main scale. Okay, so this one main scale is shifted if we make the vernier scale a rotation of one single rotation. If we use the vernier scale, the main scale shifted by 1. Okay, so by giving this vernier scale one rotation, it is actually 100 divisions we are moving, right? So 100 divisions of this vernier scale is actually causing one shift in the main scale. So obviously 100 divisions of the vernier scale is 1 division of the main scale, and here 1 division of the vernier scale is obviously then 1 by 100 of the main scale. So it's actually 0.01 of the main scale. Now 0.01 of the main scale. Now what is this main scale actually here? So it is not written anywhere on this instrument, but I know that this is in centimeter. I mean, if you were here, then we can just realize, I mean, we are accustomed with centimeter, right? So actually this is here 1 centimeter, and this is also 1 centimeter from 0. So whatever, if this is 1 centimeter, each division on the main scale is actually 1 millimeter. So obviously the main scale is actually equal to 1 millimeter. So 0.01 of the 1 millimeter means we are measuring 0.01 millimeter with the vernier scale. So with the vernier scale we can measure minimum distance of 0.01 millimeter. So that is our least count. So this is our least count, means we can measure only, not only, we can measure a minimum distance of 0.01 with our instrument here. Okay, now next I'm moving to how to measure it. Okay, see, suppose here is my lens. I mean, it's not my lens, but it's a convex lens obviously. So here, see, if I just rotate this, it will touch the surface of the glass here. Okay, now I can feel it that see, okay, yeah, okay, way to see, I can feel it after here. The glass is actually, the rotation is tightening up right here. After here, actually I'm pressing this spherometer on the lens with my hand, I'm giving a much amount of force on with this spherometer on this object, on this lens. And if I just rotate this, if I just keep on rotating, I can see here it tightens up, right? That means the spherometer is actually, I mean, this part of the pointer is actually hitting the surface of the glass, okay? And obviously we don't have to apply much pressure in this case. We can do it suppose if we just I mean guess that if it is touching a knot, and apply a plain sheet of paper and try to insert the plain sheet of paper under this. So if there is no gap, the sheet of paper will not go inside, I mean under the screw over here. So by that way we can see, I mean we can guess that this screw over here has touched the surface of the lens, okay? So I have to make sure this, okay? So here it actually touches the surface of the glass. So if you just take the measurement here, see the main scale reading it is out of focus, sorry. Okay, so the main scale reading is actually at just below 0, so I can take it as see just below 0, okay? So I can take it as 0, okay? But if it had been gone like below this line, so I could have taken it 1 below just this line, but it is just below 0 and we have a value over here, okay? See, it is 45. So I'm just considering that we have the main scale to be 0 and the vernier scale to be 45 here. So my reading is actually 0.45 millimeter. How? It is 0 plus 45 into 0.01 millimeter gives a this millimeter. So this is just 0.45 millimeter, okay, and 0.45 millimeter. So now next what we can do is we have to keep this instrument or spherometer on a flat surface. I mean, this is not a flat surface typically. We can take a glass slab instead. So you gotta put this spherometer on the glass slab and then again take the measurement, okay? So now here I am seeing that the main scale is at actually just under 0 and the vernier scale is actually at 94 like this, okay, here. So it is 0 and main scale is 0 and the vernier scale is actually 0.94. I mean obviously at 94 is the vernier scale reading, so ultimately it will make 0.94 millimeter. So that means this screw over here, I mean see, on the flat surface it is like this, and on a surface, curved surface, obviously it will be just above this point, a bit above this point, right? I mean if this is a flat surface and this is a flat surface, suppose, so it is like this, and on a curved surface it will just go above, right? So in that case, in case of a flat surface, we got this reading, and no, sorry, in this case of flat surface we got this reading, and for a curved surface we got this reading. So actually the difference is our height, okay? That is the height the screw is going up, okay? The height the screw is going up is actually what I am measuring over here, because the screw was here like this, just touching the surface, flat surface, and for the curved surface it gone up a bit, because if we just put it on this curved surface, it will it will give me a reading just some more or less this flat surface, okay? So there will be a difference. So what I'm trying to say is, now if we just take this spherometer on a flat surface and then on a curved surface, we will have a difference. Why we are having a difference? Because for a flat surface this screw was just touching the surface, and for a, just suppose these are the legs, okay, and for a curved surface the legs are like this and the screw will be just a bit above, okay? So see, if it is a flat surface then it would come up to here, but for a curved surface it will just be above this point. Okay, I'm now measuring this height. This height is actually the difference between this and this. So here the difference is 9 and okay, so this is the difference, right? So this is the difference. So this is our height. We just measured this height only. Okay, next what I'm gonna do, we're gonna measure the radius of curvature. So how to measure it? See, it is easy. If this is a curved surface, I can consider this surface is actually a part of a sphere, right? So we're gonna measure the radius of that particular sphere. Okay, suppose this is the center of the sphere, and obviously this is the radius. We have to measure this radius, right? And but we have already measured this height only. So if this is the radius of curvature, I can write, this is the radius of curvature, then I can write this is actually r minus h, obviously, because this is h. So this is actually r minus h. And if we just consider that this is d, this distance is d, then by using Pythagoras theorem, I can just write that, okay, this d square plus h, r minus h whole square is actually my r square, right? And from here I can write d square plus r square minus 2rh plus h square is actually r square. By expanding this, so see, this and this cancels out, and we are left with 2rh is equals to d square plus h square. That is, I've just taken this 2rh to the opposite side of the equals, and from here r is actually d square plus h square, by 2h. So we have already calculated this h by using the spherometer. So this was our h. Now we need to know the d. D is what? The distance from the leg and this center over here. So either I can use a scale or a ruler or whatever. I don't have a ruler in front of me, so I can use this measurement. Use a this centimeter scale here on the vernier calipers to measure the distance between this and this, rough distance. Okay, and it is actually like from 10 to 12.5. That means 2.5 centimeter. So this distance is actually 2.5 centimeter. So D is our 2.5 centimeter. This is a rough distance, and H is in millimeter. That is 0.49 millimeter. And from this, if you just substitute D and H in this equation, we will get R. So that is how we can measure the distance. The radius of curvature for this lens. Okay. So this is the way. That's it, everybody. Bye. I guess you have understood, and if there are any queries, you can ask me, you can call me. Or one thing I need to say that as you saw that here, I think I've already told you the important topics, like what is least count over here, and how we can measure the internal diameter of a cylinder, how we can measure the external diameter, and how we can measure the width of a wire with this instrument, what are the least count, what are the values of the least count, all these things. Okay, so all these type of questions can be important for the practical exam, the upcoming practical exam. And obviously in this practical I don't have any chance to give questions with the physical instruments, so you will be asked about whatever theory is related to these instruments. That's all. So bye everybody.